In this example, we have Canadian pop icon Justin Bieber, and he's being thrown horizontally at an initial velocity of 10 meters per second from the top of a cliff, and the cliff is 122.5 meters high. So we're going to take a look at how long it takes him to reach the ground, what his horizontal displacement is, and then what his final velocity is. So first and foremost, let's take a look at just writing down the vertical components and then the horizontal components. So on the vertical side, we know his change in displacement, and that's going to be negative 122.5 meters, because we're going to assume that up is positive and down is negative. So since he's going top to bottom, he's moving down. We have his acceleration due to gravity. So that is A, and that's negative 9.8 meters per second squared. And we know that the initial component of his vertical, or the initial vertical velocity, is 0 meters per second, because the question states that he's thrown horizontally. So of course that's going to state that means that there's no vertical component to him moving. The horizontal components, it's a little bit simpler. We just have one that we know of, and that is the horizontal component of initial velocity, and that is positive 10.0 meters per second, because he's going in the forward direction, right? So we're going to say that like up and forward are positive. So we can start off by figuring out how long it takes for him to reach the ground. That's just a vertical component question. So we're going to look here at part A. We're going to use our equation delta d y is equal to v1y, which is just equal to 0, plus 1/2 acceleration t squared. So we know what the change in vertical displacement is, negative 122.5 meters. We know that there's no initial velocity, so that component, that whole term is canceled out. And then 1/2 of negative 9.8 meters per second squared times time squared. So here we're just solving for t, right? So a little bit of algebra. We're going to move, we're going to have t on one side and then all the other parts on the other side. So t squared is equal to negative 122.5 meters divided by negative 4.9 meters per second squared. That gives us t squared is equal to 25 seconds squared. If I take the square root of both sides, I'm left with t is equal to plus or minus 5 seconds, which of course t is only going to be positive. So that gives us a value for time, 5 seconds. We can now take that t equals 5 from the previous part and plug that into part B. So we have our horizontal displacement is going to be equal to our horizontal velocity times time. So that's 10 meters per second times 5 seconds gives us a horizontal displacement of 50.0 meters. And since it's positive, right, we're going to say it's in the forward or the right direction, however you've set up your coordinate system. Lastly, we're going to look at the final velocity. So a couple things just to note here, the horizontal velocity is going to be consistent, right? We're assuming there's no acceleration in the horizontal plane. So what we need to find is the final vertical velocity, and then we'll have to do some component vector addition to find out what the net or the total final velocity is going to be. So if we know v1y is equal to 0, we're going to solve for v2y by plugging in to this equation here. Now this equation really is just a is equal to delta v over t. We've rearranged it. We've broken apart the delta V, and then we've had it so that V2 is on the left, V1's on the right, because we can solve for that. So that's 0. That leaves us with negative 9.8 meters per second squared. We know what the time is. Oops, the time is 5 seconds. That leaves us with negative 49 meters per second, which is to say 49 meters per second in the down direction, right? Because positive is up and positive is forward or to the right. We also know that Vx, our vertical or our horizontal component, is going to be 10 meters per second forward. More specifically, V2x is 10 meters per second forward because V is going to be consistent. V1 is equal to V2 in the x component. So if we draw this diagram, this gives us 10 meters per second on the horizontal. It gives us 49 meters per second down. This leaves us with a net or resultant vector. It's going to look something like this, and it's going to have some angle in there that we don't know. This is a right angle, and that's really important because it makes our math a little bit easier. So we can start off by labeling this here. We're going to use Pythagorean's theorem. V2 is going to be the square root of 10 squared plus 49 squared. That gives us V2 as 50 meters per second. We can then solve for our angle, which is inverse tan of 49 opposite over adjacent, 49 over 10, which is 78 degrees. So you could say something like the final velocity, therefore V2 is 50 meters per second, 78 degrees below horizontal.